All right, so we are going to be looking at something I should have mentioned a long time ago. All right, so this is not that big of a deal, but when we talk about the law of sines later, uh, I need to have mentioned it. All right, so the area of this triangle using that sine rule is 1/2, and then we did AB, so these are the legs, and angle C is the included angle there. All right, but it turns out there are two other ways that you can express this. You could have done 1/2 B and C, and then angle A would be the included angle, or you could have done 1/2 A and C, and then B would be your included angle. All right, these are all equivalent to each other. It's two adjacent legs, and the included angle. All right, that's all it is. But we're going to use this to prove the law of sines whenever that comes up. Okay. What I want to look at here is a little ACT question related to the law of sine, not the law of sines, geez, the sine area formula. All right, so I've got two triangles here, and it tells me in the problem that the area of this one is equal to 30. All right, x and y are constant on both of them, so you got the same length of those two legs, but I guess the length of the base here is changing. Yeah. So they're changing from 70 degrees to 110 degrees, but they're keeping the x and the y the same. Question is, what's the area of PQR? That's what we're after. So you may already know it. That's great. I'm going to actually spell it out here. All right. So I've got my two triangles. The area of this little one, this first one here, is 30. Now, what I'm going to do is apply that sine area formula, which is 1/2 xy, and then 70 is going to be my included angle here. All right, and this is equal to 30 because that's what the problem told me, that the area was equal to all this. Now, I'm going to solve for xy. That's what I'm going to do. I'll multiply by 2, so I get 60 is equal to xy sine of 70. Ooh. And then I'm going to divide by the sine of 70. So I get 60 divided by the sine of 70 is equal to xy. Nice. Now I go over here and I'm going to apply the little area formula again. So it's 1/2 xy, but this time it's going to be sine of 110. And I don't know the area. I'm actually going to have to calculate it. But I do know xy. All right, that's why I solve for it over here. So now I can just make a direct replacement. It's going to be 1/2, and then instead of an xy, I'm going to have 60 over sine of 70, and then times the sine of 110. Cool. And then from here, we can just throw this little beast into the calculator and see what comes out. 0.5 times 60 over sine of 70 times the sine of 110. And that does equal 30. So the areas are the same. All right. So they took the two legs here that were the same length, and they just kind of like spread them out a little bit, and the angle changed, but the triangle got shorter. That's what happened. So even though the base got longer, since the height got shorter, the area remained constant. Yeah, that's kind of neat. All right, that's it. No more sine area.